As with all museums, we rely on public support in order that we can operate. If you've enjoyed the Matilda Diaries, you can support us on Patreon. So far, our patrons have gifted us over $22,000, which we've used on various projects. Our patrons enjoy a range of rewards and come from all over the world. As it's our first anniversary on Patreon, if you join now, you'll get a special gift. If you're already a patron, thank you very much for your support. With all the components fitted to the tank, you enter what's known as a testing phase. Many of these components that have been fitted to the tank, this is the first time that they've all had to work together. It's an important part before we go out and run the vehicle with all of the decks on when we can't see what's going on. To do it safely, the tracks need to be split so that we can run the transmission without moving the vehicle. You can see that the turret's now on as well, so the suspension is all nice and leveled out, and we can check that that's fitted. One thing we had to do prior to the testing phase was practically assemble the whole vehicle because it was being used as a static display for the opening of the new workshop. And we were very lucky to have Princess Anne come and do that for us. Now it's back in the workshop. We've taken the decks off again and we've run several systems to make sure that they're all right. One of those systems was the air system which we used to change the gears on the tank. The hub of all the air system is a small compressor which sits down in between the two engines. There's an awful lot of work that's been carried out on this, and its basic operation is to generate high pressure air which is stored in a reservoir, and then on demand from the driver's gear change pedal it's released into a servo which operates the change mechanism that's mounted on the gearbox.
Without the compressed air you can't change gear from the driver's cab except in an emergency with a spanner. We've got a problem on our compressor in that the bearings, they're shell bearings like that, which fit into the bottom of the conrod. This is one of the compressor pistons, it fits around the crankshaft. Unfortunately, these white metal bearings are basically shot, so we've got to make some new ones. To that end, we've had to do quite extensive bit of tooling work. Bob Kendall, a very talented volunteer engineer, has made this mould, and we're going to cast using white metal bearing material, also known as Babbitt metal. We're going to cast some new bearings. As you can see, it's quite an extensive piece of tooling and you need quite a lot of kit to do this. We've got an old forge here which we picked up. What we'll do, it's necessary before you actually pour the metal into this mould to make the bearing, you have to warm the mould up because otherwise you shock the bearing material and it shrinks. Another part of the process is you need to put a ceramic coating onto this, which we do using French chalk with a mixture of white spirit, which you let the white spirit evaporate once it warms up, and then you'll end up with a very thin ceramic coating which stops the bearing material sticking to the mould. To get the mould warm, we're going to put it over this old forge, use the fan at the back, warm the mould up to a nice even temperature. At the same time we'll melt the Babbitt metal. Once we're in a position to pour it, the two mould halves clamp back together. Once it's cooled, we should end up with what will look something simply like a tube on that, but it will be the correct shape. It requires some machining after it's done. In order to get the hole up the centre of the bearing, there is actually a tapered plug made here, which drops down like that when you take it out. So as I say, you'll end up with roughly a tube-shaped piece of white metal bearing.
It's then machined so that the internal and external diameters are correct. Then it's parted off, split into two halves, and the oil galleries are cut into the inside of the bearing so it remains lubricated while it's in operation. The two halves can then be fitted to the crankshaft.
When that's done, it will then fit into the conrods correctly. We may have to do a little tiny final bit of scraping, and then go around the crankshaft to the compressor, and hopefully we'll have a new all functioning compressor. It's very important because This compressor crankshaft operates at 2000 RPM, so it's very important that it's got good bearings and a good oil feed.
Prior to putting the compressor in between the engines and running it off of the cross drive, we came up with a way of running it on a lathe and charging up another compressor bottle to make sure that it was generating the high pressure air that we needed. As you can see, the turret's now back on. Because of its size and its weight, it's quite a complex task in its organisation, but providing it's done carefully, it's actually quite an easy operation with the lifting gear that we have. The first thing that went in was the turret basket, which is the internal components of the turret that the crew stand on and allow the crew to stay in place when the turret's revolving. Placing the turret on the tank is quite a daunting operation because of its size and its weight, but providing it's done carefully, it's actually quite an easy operation.
Down, right, hold it there.
For the opening of the new workshop, it was necessary to reconnect the tracks in order to get the vehicle down and on display.
One, two, three, go! Hold it. 1, 2, 3, go!
There are 69 links in one track. In order to connect the tracks back together, it's quite an unusual system. It involves a pin and 2 collets, which we managed to get brand new from Australia. The pin goes in the track to join it initially, and then the 2 collets are hammered on either side of the track pin in order to lock the pin in place.
Hang on. Ready?
Yeah.